Welcome to This Explainer. Today, we're skipping past those tired Hollywood cliches and jumping straight onto the manufacturing floor of tomorrow. The blueprint for our future? Well, it isn't just being drafted. It is literally being assembled right now as we speak. We're going to break down the absolutely incredible rise of humanoid robots. We'll look at how they're engineered, the intense ways they're tested, and how they're already stepping out of high-tech labs and straight into our messy, chaotic daily lives. The future is unfolding right in front of us, so let's figure out exactly how it works. Now, picture this, glowing blue eyes opening up. But hey, this isn't some dramatic movie scene. It's an incredibly complex machine booting up for the very first time. It's really the starting gun of a whole new technological revolution. We're finally moving way past those stationary factory arms and predictable wires, and stepping into the realm of creations that actually mirror our own unpredictable human form. But you might be wondering, how do we actually get from a bunch of parts on a quiet lab table to a fully autonomous walking humanoid?
Okay, let's dive right into this. Section 1. Building the modern humanoid from blueprint to reality.
The sheer physical complexity of what these engineers are putting together is, frankly, staggering. We're actually at a point where we use advanced robotic arms just to build the humanoids themselves. Inside, precision motors act just like muscles, giving them these incredibly fluid, controlled movements. But you know what the real engineering marvel is here? The hands. Replicating the 27 bones and that super complex tendon structure of a human hand, well, that often takes more intense engineering than the entire rest of the robot's body combined. Add in a network of integrated sensors and cameras acting like a high-tech nervous system, and you've got an absolute masterpiece of precision hardware.
But here's the thing. A beautifully built robot body is completely useless if it doesn't have the brains to navigate our very messy world. That's where AI-powered vision and speech systems come in. They're the ultimate bridge. This isn't just about programming a machine to walk in a straight line anymore. No, it's about giving it the ability to understand chaotic, totally unstructured human environments in real time. This tech lets the robot spot a specific coffee mug on a cluttered desk or actually understand context well enough to respond naturally to your voice commands. Honestly, it's what turns a mechanical tool into a truly interactive entity.
Of course, before these brilliant machines ever get to see the outside world, they have to survive a brutal physics gauntlet. For us humans, standing up or walking is just second nature. But for a top-heavy machine, maintaining balance is a constant, wildly complex math equation. Think about climbing stairs. Most of us do that half asleep in the morning, right? But for a humanoid, it requires millions of real-time micro-adjustments. They have to master avoiding dynamic obstacles and picking up fragile objects without dropping them. It's literally a high-stakes obstacle course, perfectly designed to guarantee they're ready for the completely unpredictable nature of our actual world. Let's move on and see how this spills out in the wild. Section 2. Robots in the real world, leaving the laboratory. So we aren't just talking about abstract closed-door science experiments anymore. Humanoids are out there right now, tackling highly practical, everyday tasks, and the impact on humans is already huge. In hospitals, these bots are handling complex logistics, fetching supplies and moving things around, which fundamentally frees up nurses to actually spend their valuable time caring for patients. Over in massive warehouses, they're taking on grueling inventory tasks and heavy lifting, literally saving human spines from repetitive stress injuries. And it doesn't stop there. From guiding visitors through sprawling public buildings to actively testing package delivery right in our own neighborhoods, their integration into our daily routines is already well underway. But the true test for this tech, that happens in environments that are actively hostile to human life. Sure, precision is absolutely paramount on intense factory floors and inside cutting-edge research labs where humanoids are already putting in the work. But their versatility really shines in the extremes. We're deploying them into disaster response training zones and intense space mission simulations. We're talking about places where human flesh and bone just simply cannot survive. When you see a machine easily navigating an environment that would be lethal to us, the true expansive potential of this technology becomes pretty much impossible to ignore. Now, we have to look at the big picture impartially. Section 3, the risks and rewards. A balancing act. This massive technological leap forces all of us into a really delicate balancing act. On the one hand, the advantages are undeniably massive. We're looking at historic boosts in global productivity, absolutely crucial improvements in accessibility, and the profound safety advantage of sending machines into dangerous jobs instead of people. But on the flip side, for every single leap forward, we face a counterweight of equal size. The development costs are just astronomical, and there are still serious technical and safety limitations when you have heavy, powerful machines operating right next to humans. Plus, we're entering completely uncharted ethical territory when it comes to autonomy, not to mention the inevitable major disruptions to the global workforce. We absolutely have to weigh those immense productivity boosts equally against these incredibly complex societal shifts.
Which brings us to our conclusion. Section 4, our new everyday partners, looking to the horizon.
We've been on quite a journey today. We've gone from the intricate assembly of precision motors in dark laboratories through the grueling physics of mobility testing, all the way out into the complex reality of hospitals, disaster zones, and space simulations. And now we find ourselves standing right at the edge of an entirely new era. The philosophical weight of this widespread integration is immense. We're transitioning from viewing these creations as just simple tools to seeing them as potential collaborators. It really forces a fundamental reevaluation of how we interact with technology as we try to balance those profound rewards with some truly unprecedented societal challenges.
So, I'll leave you with this. Will humanoid robots become our everyday partners? It is the ultimate question we absolutely must consider as this technology continues to evolve and rise. Thank you so much for joining me for this explainer. Keep learning, keep questioning, and I will see you next time.